So to simplify a trig expression like this, we just have to use all the trig identities. So in this case, it's sine and cosine already, because one of the tricks is when you don't know what to do, make everything be sines and cosines. It's already sines and cosines. The denominator is the thing that's more complicated, so you cannot split it to two fractions like you could if this was the reciprocal. You could split it into two fractions. So this is pretty close to a Pythagorean identity. 1 minus cosine squared would be a Pythagorean identity. So let's make that be 1 minus cosine squared. If you multiply by 1 minus cosine, you get 1 minus cosine squared in the denominator. So you get sine, I'll distribute, minus sine cosine over, now FOIL that out, you get 1 minus cosine squared. And 1 minus cosine squared is sine squared from the Pythagorean identity. We have sine of x minus sine x cos x over sine squared. Which we can split into two fractions. Now that the denominator is only one piece, we can split it to be sine over sine squared minus sine x cosine x over sine squared. So the sine on top cancels one of the signs on bottom, so that's 1 over sine. Sine on top cancels one of them on the bottom, so that's minus cosine over sine. And then that can be simplified just a little bit because 1 over sine is cosecant. And then cosine over sine is cotangent. And that is as simplified as it gets.